Now we are going to hear from Patrik Rokyta, who's VP Systems Architecture at NetNumber. And Patrik is going to talk to us about the programmable telco network. Thank you, Patrik.
Thank you, Annie, and hello, everyone. Thanks again for having the opportunity to take part in this event. As mentioned, my name is Patrik Rokyta. I'm the Vice President of System Architecture at NetNumber. Our headquarters are located in Greater Boston area, Massachusetts, in the United States of America. And I'm glad to elaborate on aspects of telco network programming in a sense that we will mainly talk about deployment automation using different technologies in order to achieve the best flexibility and agility across the network services that are offered in the residential or enterprise market. Can we please advance the slide? Thank you. So before we go to the actual network programming, we need to talk about the refactoring of the telecommunication products as we know them from the legacy or even 4G times. In those deployments, the products were mainly referred to as so-called network elements. They were quite monolithic and have incorporated a lot of functionality. And with that, the deployment and the integration was basically quite straightforward based on suppliers delivered MOPs. But when it comes to delivering flexibility, agility, upgrading, moving this networks element, that was quite a bit of an exercise because moving such a monolith is much harder. And any failure in upgrades or in any operation applied to this monolith could significantly degrade the service the network element is involved in. And this was accepted for quite a long time, also due to the fact that 4G was mainly built on network function virtualization, having the decoupling of the software from the underlying hardware in focus. And also, let me say, due to the fact that the communication service providers and the suppliers traditionally didn't compete. And now with 5G and also with the increasing and important role of the hyperscalers in the transformation to cloud native, they will be push for transforming this traditional deployment model to a cloud native ecosystem. And also there will be an increasing competition scene between the communication service providers and the hyperscalers, especially across the enterprise market. So this basically creates the need for the communication service provider to transform the operations from the traditional deployments to cloud native. And the cloud native transformation that has already happened across the IT industry, and we benefit from it during every day of our private and professional life, that involves the use of hyperscalable microservices architecture and utilizes container technology that makes the deployment portable across different types of infrastructures, whether it's virtual infrastructure, cloud infrastructure, or whether even physical infrastructure is utilized in those deployments. And while this transformation is happening, allowing the operators to move around a smaller pieces of software referred to as the containers, that makes especially technologies or procedures like continuous delivery, test and deployment possible. The agility in how to adapt or change the communication service offering to the needs of, let's say, enterprise or residential customers. That degree of agility and flexibility is mainly dependent on how the operator and its suppliers manage to bring automation and programmability into the deployment of the networks and network services. So let's move to the next slide and let's elaborate on how a typical deployment of a network service or consisting of one or multiple network functions look like. We usually need to observe two aspects in critical communication service offerings, which is the availability of the service. And the availability of the service, let's say the high availability of the service, is maintained locally by local redundancy of the service at one location or point of presence. And at the same time, the same service can be delivered also from a geographically distributed location. So we usually see at least 2 data centers that are able to deliver the communication service in question. And then any data, seldom the state, is synchronized across these two data centers. So when it works, everything is perfectly fine, but the main task is about how you basically deploy this network service, and then also how you modify it any day during the uptime of the service. And we already know very well how to manage the infrastructure. We learned it from the network function virtualization times, but with the deployment management, that area has significantly changed or improved with the introduction of cloud native ecosystems, because simply with the cloud native transformation, the amount of units that you need to manage as part of the network service have significantly increased. So this is nothing you want to touch manually or based on mobs. That's simply a vast amount of moving parts that you would need to orchestrate and manage. And with that, the cloud native ecosystem already has delivered facilities and tools that provide for orchestration and lifecycle management of cloud native services. And the deal is basically to leverage on the benefits of this existing software and use it accordingly, so that the agility and flexibility of your network service offering can significantly increase. So today we will mainly concentrate on the deployment management that you see as a gray box connected to the deployment on each of the points of presence. But I also want to highlight that there is a lot of activity ongoing in the management of the wide area network infrastructure. So software-defined networking and the management of the network infrastructure in the wide area network is also something that gains a lot of attention. But also as of my role and as of the role of the company I work for, we will concentrate on the deployment management. And here the agility can be achieved at different levels. I will mainly concentrate on achieving the basic agility that includes defining or declaring the network service as code. So in case of sending a set of imperative commands to the deployment to set up and maintain and modify the system, it's the better approach that we know from the cloud native ecosystems to declare the state of the system and then allow the tools to basically identify any difference between the current state and the defined state and adjust the system state as needed. And also with the smaller deployment units referred to as the containers, there is much better flexibility in testing functional or functional upgrades or bug fixes by introducing so-called blue-green or canary rollouts. This allows the operators and also to the suppliers during the integration process to test updates and incremental updates or functional add-ons in much safer way, and also with the possibility to immediately roll out any faulty deployment within few seconds or minutes. So that was not really possible with the network element-based deployments. With microservice-based architectures, there is much more flexibility in testing, upgrading, or rolling back new functionalities. And of course, what is also necessary is, because you don't or cannot touch every piece of software manually in cloud native ecosystems, to have sophisticated APIs to manage configuration and deployment. And one of the approaches here to adopt the open API spec that describe generic operations to the deployment that are even standardized. So as long as the suppliers adhere to these standards for configuration and deployment management, there is lots of interoperability possible across multiple vendors, so that the integration cost on the operator side can be significantly optimized. I mentioned the config and deployment, so let's go to the next slide and spend a few words on the config. I'm spending this slide because, in my opinion, it's necessary to have the right approach and thoughts around the configuration. So there are the two aspects. One is the configuration and one is the deployment. And basically, you have the two choices. You can make your configuration part of the deployment that you see in the upper part of the slide, or you can separate the configuration from the deployment. When you run configuration as part of the deployment, then of course there will be some deployment artifact that the supplier will define with the release of the product that contains the default values of the configuration of the network service or network function in question. And when this product shows up on the premises where it needs to be deployed, then these default configs will be overridden with deployment specific values. And then you basically instantiate your service. This service, using the deployment specific configuration, now will come up and will be ready for management. And then you usually hook in via open APIs to activate the service the way you want. And then you proceed with day 2 configuration updates as needed. The trick is here when you need to redeploy the system, because you need to change, modify, add some of the deployed components, whether it's a container image update, or whether it's some tweak to the service definition, whether it's some tweak to the IP addressing, to the external IP addressing of network service network function. That basically creates the risk that your deployment artifact that represents the configuration will be also redeployed, and you could lose your day 2 configuration updates. So also, as mentioned in 12-factor rules, before you redeploy your system, create a new release of the deployment, you must migrate the deployed configuration back into the deployment, which is possible, but may not be all the time convenient. And therefore, the other approach is separating configuration from the deployment, where you basically use a configuration store, and then this configuration store can be already uploaded with configurations that the network function, network service will need. And with that, once the service starts, it connects to the store, uploads its config, and immediately gets ready for service. And because you just operate between the deploy and the configuration store, you can basically update the configuration as needed. You always have a single source of truth. So both approaches can be implemented. There is no deal with both of them. Just again, for the one approach where configuration is part of the deployment, you need to take care of correctly migrating the day 2 configuration changes back into the deployment process. Let's go to the next slide and talk about what management options we have from the deployment perspective. And I am elaborating on 3 different approaches. One on the left is using the deployment server. That is basically a facility and a process delivered by the supplier. And then there are 2 additional approaches that are mainly coming from the 3GPP and ETSI standards. One is the 3GPP management services on the top that includes the provisioning API, where many people would think this is just good to provision some network function specific data, but it's also very well suited for controlling the deployment topology. And then there is the ETSI-MANO on the right that we already know from network function virtualization times, that is now being made cloud technology aware, so that also containerized workload can be managed using the ETSI-MANO architecture. So on the next slide, we will see how the deployment server can be utilized in deployment automation. And the benefit of this approach is, especially in deployments where the operator may not have the target deployment automation processes in place. There might not be any NFV-MANO architecture deployed, or the operating system is just implemented or mainly focusing on fault supervision and performance assurance rather than controlling the deployment itself. So, you know, the suppliers, they always have a kind of facility and processes in place to instantiate and lifecycle manage the network service and network function they deliver. And that's what I refer to as the deployment server. It's completely self-contained. It's a vertical. It is basically a turnkey solution, and therefore comes with low integration cost. The benefit for the communication service provider is that it's fully supported by the supplier, but of course, it's a single vendor solution, so it will probably have limited interworking capabilities in terms of multi-vendor interoperability or multi-tenancy across deployments of different vendors. It's simply single vendor specific, but it still has its great benefits because it basically allows the operator to get network functions from the supplier deployed and operated in a nice and automated way. And it comprises different level of management. It can manage the infrastructure in case the supplier is responsible for infrastructure management in terms of setting up, creating VMs, spanning Kubernetes clusters across the VM, which is referred to as the container cluster management, and then spinning up services for container image registry or for Helm chart repository, so that the entire container cluster and its services is made ready for deployment and management of the containerized workloads. And that happens mainly by utilizing the Helm client, that is the upstream packaging framework for Kubernetes. And there will be, in addition, deployment automation services that will consume artifacts from the artifact repository and automatically apply administrative tasks to the deployment. Yeah, so upgrades or dynamic expansions of volume, or making node ready for maintenance, taking it out of the deployment, isolating it from the deployment so that no workload is scheduled on that node for the time of the maintenance. That all may be automated using the deployment automation services. NetNumber, in order to maintain as much interoperability as possible, is using upstream services, upstream components in its deployment server. It's based on Artifactory, Helm, Kubespray, Terraform. So all tools that are widely known and widely used in that area. And we therefore believe that this creates the least vendor lock-in for the communication service provider. We now move to the last slide that is showing how the management is done, let's say, in more standard conformant way. And I'm talking about Telco Standards here. The deployment server is more utilizing the IT-based way to deploy and manage a containerized workload. So this slide is mainly focusing on how the Telco Standards define the deployment and management of telecommunication services. And on the top, you see the 3GPP OSS, and on the right, you see the ETSI management orchestration framework that is being defined for containerized workload as of the release 4 of the ETSI specifications. And the combination of these services allow the operator to define, deploy, and manage a communication service. The communication service can be even deployed across network slices and network slice subnets. So the 3GPP did a great job on evolving the OSS management service capabilities to cover the needs of the 5G core. But it also simply continues with maintaining the open API specs for the provisioning, for supervision, performance assurance, and other management services. And we did a proof of concept on how the provisioning management service can be used for controlling the configuration and the deployment of a cloud-native microservice. And I wish you would have seen the results. This is really impressive. So my message to the audience is that the provisioning management service can be very well used for the deployment and lifecycle management of configurations and deployments. It's based on network resource model, and it's a generic model that allows you to control all aspects of your network service deployment at any granularity level. But you also know the ETSI-based approach that has been born with the network function virtualization, and also there the standards, even when currently on the way for release 4, are evolving to cover the aspects of containerized workload management across virtual or cloud infrastructures. And here the traditional orchestrator and VNF manager is enhanced with the cloud native function management system that can also consume as any other deployment task Helm charts and OCI compliant containers, and by communicating with the registered Kubernetes cluster can instantiate and orchestrate the workload on the target managed container cluster. And there is a lot of discussion about how much the functional and responsibility overlap between 3GPP and ETSI shall be, but there is also much work on aligning these two worlds by the means of the SOL 005 interface that basically allows the OSS, the 3GPP OSS, to control the deployment via open API operations from within the ETSI management orchestration system. So there is a interworking interface defined, and therefore you can clearly define the split of responsibility. You can also, as mentioned, see a lot of functional overlap. NetNumber also has research that ETSI-MANO ecosystem just recently as part of the open source MANO OSM Hackfest, and came basically to the conclusion that the deployment and configuration, instantiation, and lifecycle management can be done using all three deployment options: deployment server, 3GPP OSS provisioning management service, and the ETSI-MANO framework, by simply reusing the very same deployment artifact. So that gives us quite nice choice to address and satisfy the capabilities of our customers, depending on what part of the ecosystem they prefer to use for the deployment and orchestration of the network services. With that, I'm at the end of my presentation. NetNumber delivers signaling, security routing, and global data services to the telco industry. That's what we are known and valued for. And we have evolved our legacy platform towards an intergenerational platform that allows the deployment of legacy and containerized workloads on the infrastructure of customer choice. And with that message, I hand back to Annie. Thank you for your attention, and I'm ready to answer any question in case there is time for that.
Thank you, Patrik. We do have a question. Which SDN tools do you use to include in your, which SDS tools do you include in your programmable networks product? Mm-hmm. Is it a standard or still an unregulated software-defined product? Thanks.
Good.
I guess you kind of have addressed this in what you just said, right?
Yeah. So I will not mention any tools for the SDN management. What we're currently elaborating on is how to orchestrate and manage the wide area network between the data centers. We are probably not the perceived vendor for those tasks, but we see that with the ETSI management orchestration architecture and the ETSI-driven implementations in that area, we can use the open source MANO that comes from the ETSI community to do exactly that job. Yeah? And with what tooling, whether it's ONOS or other stuff, that is not yet subject to any decision at NetNumber from what I know.
Okay, I think that's it. Thank you very much indeed, Patrik. Interesting and a huge amount of information.
Thank you very much. Have a good day.